So we're going to continue on with exponents. I think this moves into another worksheet. These are a little more challenging as they move further into it. And again, for the most part, we're probably not going to use this math anywhere but probably in our math classes. Now, if you go on to calculus and things like that, you may actually get to apply some of this information. I have not yet to apply this anywhere in the real world. I do like this. I kind of like this math because it's kind of like puzzles. I enjoy puzzles, so it's kind of more like a math puzzle that you can just kind of play with. So let's look at this first one. I have x to the fourth raised to the negative third times then 2 times x to the fourth. Now, I do see a negative exponent, but since this is a power to a power, I don't mind multiplying integers, positive negative numbers. My issue a lot of times is with adding and subtracting. That's why I kind of, on those other examples, since I was kind of doing this adding and subtracting thing, I went on and got that negative exponent out of the way first. But since this is multiplication, I don't mind to leave that negative in there until a little bit later on into the problem. So when I see a power raised to a power, that says I can multiply 4 times negative 3, and that's going to be x to the negative 12th times then 2 times x to the 4th. Now, the x to the negative 12th means that's going to move to the bottom. So I have 2x to the 4th, and then you can have x to the 12th on the bottom. Now I do see that these are the same bases, and I'm dividing, so that implies that I can take away, I can mark out. I can mark out 4, but I'm still left with 8 on the bottom. So I have 2 over then x to the 8th power. Notice how, again, I'm not really using this rule as much as I'm just kind of mentally just marking things out in my head. But you could say, well, 12 minus 4 is 8. Then I got to pay attention to that there's more on the bottom, therefore that x to the 8th is in the denominator. So 2 over x to the 8th would be your final answer on that one. So these simplify to an x to the 8th and it goes on the bottom. Next example, I have x times y cubed times 2 times y squared raised to the 0 power. We do pick up on that anything raised to the 0 power turns into a 1. Since this whole thing is in parentheses, that 0 has power over all of it. So that means all of it's going to turn into a 1. So I have x to the 4th, y to the 3rd times 1. But again, multiplying by 1 really doesn't do anything, so I can just throw it out of the problem. It absorbs. When you multiply by 1, it's just the identity. It can be just dropped out. So I have x to the 4th times then y to the 3rd. That's my simplified answer. My next example, I have 2m to the negative 4th, and then I have this 2m to negative 4 raised to the 3rd power. Again, I want to go ahead and get rid of this first, so I'm going to go ahead and bring the power through the parentheses before I mess with the numerator. So I'm going to leave the numerator alone for the time being, because that needs to be simplified first before I deal with the numerator. So again, with fractions, I always try to simplify the numerator and denominator first before you start mixing the two together. And I know that since you have a power on the outside and there's two things on the inside, this power goes to both pieces. So it's kind of like this property. You multiply it to both of them. But remember, when there's a 2 there, it's understood to have an exponent of 1. So that 3 times 1 makes that then a 2 to the 3rd power. And then 3 times negative 4 would be a m to the negative 12th. Now, what I'm also picking up on, 2 to the 3rd power is the same thing as 8. But I also pick up on that there's division going on here with 2's. So I'm thinking, let's just leave it like that for the time being. But notice how these have negative exponents. That means this m to the negative 4 is going to go to the bottom. This m to the negative 12 is going to go to the top. So this 2 stays put. This m to the 12th goes to the numerator. This 2 to the 3rd is going to stay put. And I have that m to the negative 4 is going to go to the bottom as m to the 4th. Now some things I pick up on is there's a 2 up here and there's 3 2's down here. That means I can divide out a 2, and I'm left with a 2 squared on the bottom. I also pick up on, that's simplified out. If I have 12 m's on the top and 4 m's on the bottom, that doesn't look like that. Let's make that a little bit more like an exponent. So if I have 12 m's on the top and 4 m's on the bottom, I can divide out 4 of them. I'm left with 8 m's on the top. Now remember, 2 squared is the same thing as 4, so I can write that as m to the 8th over 4. That would be my simplified answer in that example. Okay? So there are some nuances to this to kind of play with, and it just kind of takes practice and going through examples to get more familiar with that. I think I'm going to do one more set of examples, and I think that's going to be about it for this part of it all, so stay tuned.